centripetal acceleration is a linear acceleration, although the object is moving in a circle, in a circular motion, but centripetal acceleration is a linear acceleration because it is moving in a straight line directed towards the center. Okay, although the object is moving in a circular motion. So you've got to know. And since an object that is moving in a circular motion is having a centripetal acceleration, there must be an origin. There must be a quantity that caused this centripetal acceleration. And we all know acceleration is generated by a net force. Therefore, there is a net force acting on an object that is moving in a circular motion. So when an object is moving in a circular motion, all right, there is a centripetal acceleration directed towards the center of the circle. And this centripetal acceleration is generated by a centripetal force. Is generated by a centripetal force. All right. So that centripetal force is actually a resultant force. So because I've already told you that if there's acceleration, F equals to ma. If there's an acceleration, that acceleration is generated by a net force, resultant force, and that force is centripetal force. So centripetal acceleration is generated by centripetal force. Now, in the previous lessons, I've already told you, the direction of the acceleration must follow the direction of the motive force, must follow the direction of the net force. All right? Therefore, since your centripetal acceleration is that direction, your centripetal force must also be acting in that direction. This caused that. Always remember, this caused that. So there is a centripetal acceleration. All right. Now, centripetal acceleration is an imaginary force. What do you mean by that? That means in an actual object that is moving in a circular motion, the contributor of the centripetal force by nature is some other force. That means it could be a frictional force, it could be a gravitational force, it could be tension in the string. They are the one who are providing it. They are the one who are providing the resultant force. They are the one who are providing that net force and give that centripetal acceleration and make the object move in a circular motion. And we call the tension that causes that. We call the gravitational force that causes that. We call the frictional force that causes that as the centripetal force. So centripetal force is just a general term used to refer to the force in a circular motion that causes the centripetal acceleration. All right. So I want you to know that. Okay. So meaning, if we were to talk about an electron that is moving around the nucleus, so I can ask you, okay, state the centripetal force. So I can ask you, okay, what causes the electron to move around the nucleus? So if you were to say the centripetal force causes that, you're only giving me the general concept because it's circular motion. All right. So if I say name the force, all right, actually I'm asking for a specific force. So here it will be electrostatic attraction, electrostatic attractive force. Okay, electrostatic attractive force. Now, in the case of a string, so let's say this is a string that's a stone and it moves in a circular motion. All right. So what caused the stone to move in a circular motion? Of course, there's a centripetal force, but that's a general term. What's the name of the force? The force is actually the tension in the string. So here, the tension is the centripetal force. That means the centripetal force is the tension in the string. Now, you also know that the moon moves around the earth. This is your earth. So the moon, all right, moves around the earth in a circular motion. All right. So what causes the moon to move around the earth in a circular motion? Of course, it's centripetal force, but that's not the name of the force. That's a general cause. Sorry, that's a general term. The name of the force will be the gravitational force of attraction between the moon and the earth. So I put it as Fg, gravitational force. It's a gravitational attractive force between the earth and the moon. So all this are the centripetal force. So what I'm trying to say is the centripetal force comes in many forms. All right, so identifying the many forms of the centripetal force is important. That's the name of the force. When a car takes a corner, when a car takes a corner or moves around a corner or moves around a curve, that part where the car is moving around the curve, that part where the car is negotiating the corner is actually part of a circular motion. Therefore, there must exist a centripetal force. Otherwise, the car will skid. Now, what provides the centripetal force? It's the frictional force between the tires of the car and the road itself. So again, the centripetal force comes in many forms. So you got to understand that. But generally, in any circular motion, if I ask you to name the force, it is centripetal force. So centripetal force is a general term referred to the force that causes the circular motion. Okay, and it is a resultant force. It's a resultant force. So now let's come to the properties of the centripetal force. So number one, centripetal force causes circular motion. In other words, in order for circular motion to exist, you need centripetal force. Number two, centripetal force is the resultant force, and it causes centripetal acceleration. So it causes centripetal acceleration. Now the third point. So since you know that it acts along the radius, that means it's a radial force. And in the previous lesson, I've said that the object in a circular motion, direction of motion is tangential. Tangential motion. The direction of motion is tangential motion. This one I specified in the previous lesson. And today I'm saying the centripetal force is directed towards the center, therefore it's a radial force. The motion is a tangential motion. So indirectly tells you the centripetal force is perpendicular to the direction of motion. The centripetal force acts perpendicular to the direction of motion. So that's the next property. Perpendicular to the direction of motion. Okay, so remember, it's perpendicular to the direction of motion. All right. Now, let's go back to work that we learned under the previous lesson. So what's the definition of work? Work is defined as the product of force and displacement. But you cannot stop there. You must continue to say that whereby the direction of displacement must be equal or must be the same as the direction of the force. So only when the direction of displacement is in the direction of the force, or only when the direction of force as a component of displacement in that direction, there will be work. If there is no component of displacement along the direction of force, work will not be done. Now, keeping that in mind, let's come back to this. Now, you should know the direction of motion is tangential, which means it's perpendicular to the centripetal force. So does the centripetal force do work? That means during the circular motion, is work done? Is there work done? And who does the work? This is the force that does the work because this force causes the circular motion. So does centripetal force do work? So we go back to the definition. We say that in order for centripetal force to do work, there must be displacement in that direction. There must be displacement in that direction so that it's in the same direction of the force. But there can never be a displacement in that direction because our object is moving in that direction. If it is moving in that direction, displacement must be in that direction. So in a circular motion, displacement is always perpendicular to centripetal force. So being perpendicular, the centripetal force never does work during the circular motion. Conclusion, during a circular motion, work is not done. All right? So during a circular motion, the object that is circulating will not do work. The electron does not do any work when it's moving around the nucleus. The stone does not do any work when it's moving in a circular motion. When the moon revolves around the earth, it doesn't do any work. Now, according to the work energy theorem, The relationship between work and energy is, all right, work can be transformed to energy and energy is used to do work. So if work is not done, there's no transformation into energy. Meaning, if we interpret it correctly, in other words, any object that moves in a circular motion does not lose energy. Does not lose energy because it is not doing work. Only when an object does work, it loses energy because the energy is transformed through the work it is done. But here, no work is done. So what am I trying to say? An object that is moving in circular motion will continue to move in circular motion perpetually throughout. That is why the moon revolves around the sun throughout. You take a satellite, you put it in orbit in space, it'll keep on going around the earth. You don't need to go now and then and put in energy into it, don't it? Because it doesn't do work, it doesn't lose energy. Energy in the satellite is only required for transmission purposes. So we supply or we equip the satellite with solar cells and all that for transmission of data and information to operate the electronic gadgets we implant into the satellite for that purpose, but not for it to move in a circular motion. Correctly must be understood. Accurately must be known. All right? Okay. So that is as far as centripetal force is concerned, as far as work done is concerned, and so on. All right? Okay.